flooding emergency that is stretching along the Gulf Coast.
Be a big threat for those along the coast.
And an order renaming it the Gulf of America.
Canadians are making a mass exodus, and now businesses on our Gulf Coast saying they are feeling the impact.
A watery expanse that's seen centuries of storms, commerce, and exploration. But now, something is stirring beneath the waves. Recently, scientists have detected abnormal seismic activity deep below the Gulf's surface.
In the Gulf are going to be a big threat for those along the coast. We want to continue our team coverage by heading down to Lee Peck, who is live right now on Dolphin Island, checking
Activity they once feared might come true. Fault lines that had been dormant for centuries are beginning to shift. And what's more, there are signs this might only be the beginning. Are we witnessing a natural adjustment of the seabed, or the early warnings of a massive seismic event? A silent shift beneath the sea. The Gulf of Mexico is best known for its warm waters, vibrant marine ecosystems, and oil-rich seabed.
An earthquake hit the Gulf of Mexico about 160 miles southeast of New Orleans. The quake was registered as 4.5 on the Richter scale. National Weather Service said there is no threat of a tsunami.
But there's a lesser-known side to this vast body of water, one that lies hidden beneath miles of sediment and salt. Few people realize the Gulf is riddled with ancient fault systems. These deep fractures in Earth's crust span hundreds of miles and intersect with major tectonic transition zones, including the edges of the North American plate and the unstable regions near the Caribbean. For decades, these faults were believed to be mostly inactive, quiet remnants of a more turbulent geological past. But recent research is changing that narrative. Seismic sensors along the seafloor have recorded a spike in tremors, some of which are too deep to be detected by traditional land-based instruments. More troublingly, some of these tremors occur in sequences, in patterns that suggest the movement of deeper tectonic slabs. Recent bathymetric surveys have also revealed subtle undulations in the seafloor, rippling features that suggest active deformation. These ripples align with known fault orientations, indicating that tectonic stress may be building along pre-existing weaknesses in the crust. Marine geologists have also noted a growing presence of mud volcanoes and hydrothermal vents along the seabed, features commonly associated with tectonic plate boundaries or crustal disturbance. These formations not only release heat and gases from deep within the Earth, but also serve as pressure valves, early indicators of shifting geological structures. In addition, ship-based gravity surveys have detected anomalies beneath the Gulf's floor, zones where the gravitational field is slightly altered, likely due to differences in crustal density. These anomalies often correlate with areas of tectonic activity, suggesting that the deeper rock layers may be undergoing stress redistribution. One marine geologist put it bluntly, "The Gulf is waking up." What scientists found. Using cutting-edge technology like multi-beam sonar, marine LiDAR, and ocean-bottom seismometers, researchers from NOAA and partner universities have recently mapped a series of active fault zones beneath the northern Gulf. This high-resolution mapping effort represents one of the most detailed surveys ever conducted of the Gulf's subsurface geology. They found linear displacements along the seabed, stretching for dozens of miles. These weren't simple landslides or sediment slumps. They were clean, sharp offsets, signs of tectonic shearing and lateral fault motion, often with vertical displacement of several inches to feet. In some cases, the offset lines were so geometrically precise that researchers described them as textbook fault traces, cutting across the seabed like surgical incisions. In one segment, south of Louisiana, researchers observed the seabed rising by several centimeters over a matter of months. In another area, closer to the Florida shelf, satellite altimetry picked up subtle bulging, an indicator of crustal uplift. The shifting appears consistent with slow slip events, a phenomenon observed in tectonically active zones where faults gradually slide without causing immediate earthquakes, though they may increase pressure in locked fault sections. These kinds of silent precursors have been recorded in places like the Cascadia subduction zone and the Nankai Trough off Japan, both capable of generating megathrust quakes. But it's not just the movement, it's the heat. Thermal imaging has revealed localized hotspots in the seabed, anomalies that point to rising geothermal gradients, possibly due to friction along fault lines or the upward migration of deep crustal fluids. These anomalies have shown temperatures as much as 12 degrees Celsius higher than expected at comparable depths, indicating potential hydrothermal circulation. In one particular site, ROVs captured shimmering heat haze, an effect known as thermal venting, usually associated with volcanically active mid-ocean ridges. In several places, gas seeps have begun to appear, methane and helium bubbling up from cracks in the ocean floor. These gases, particularly helium-3, are often associated with deep Earth activity. Helium-3, in particular, is rarely found near Earth's surface unless transported from the mantle, suggesting tectonic conduits may be forming or reactivating. Similar signatures were detected near tectonic rifts in the East African Rift Valley and the Taupo volcanic zone in New Zealand. Researchers have also recovered core samples from around these anomalies. The cores reveal disturbed sediment layering, fractured bedrock, and increased concentrations of heavy metals, often a hallmark of crustal fluid movement. Some samples contain unusually high levels of arsenic, antimony, and barium, metals often found in hydrothermally altered environments. These geochemical signatures align with known stress migration patterns seen in other subduction-adjacent zones. What's more, microbiological sampling in the same regions has yielded extremophiles, heat and pressure-tolerant microbes that typically thrive near hydrothermal vents or in fault-generated fluid pathways. Their presence may hint at a deep biosphere fueled by Earth's internal energy, hidden beneath what was once considered a relatively stable and inert basin. All of this paints a picture of a dynamic, reawakening fault system, one that geologists previously thought was long past its prime. The data now suggest that rather than fading into geological dormancy, the Gulf fault systems may be entering a new phase of activity, slowly reshaping the basin from beneath. This raises urgent questions. Could the Gulf be more tectonically active than previously assumed? And if so, what might that mean for coastal infrastructure, oil platforms, and the millions who live along its shores? The Gulf fault lines, an overlooked threat. While much attention is paid to the San Andreas Fault or the Cascadia subduction zone, the Gulf fault lines have largely escaped public scrutiny, but they are no less dangerous and may present unique and underappreciated threats due to their geological setting and human activity directly above them. One major system, the Sigsbee Escarpment Fault Zone, runs parallel to the Louisiana-Texas coast and connects indirectly to deeper fault systems under Mexico's Sierra Madre. Another, the South Texas Fault Zone, extends inland across southern Texas, crossing populated regions like Corpus Christi. It has shown periodic, low-level seismicity for decades. The Perdido Fold Belt, extending beneath the Western Gulf, also appears tectonically linked to subsurface movement along the Mexican margin. Seismic reflection studies reveal deep warping of crustal layers, evidence of ongoing compression and deformation. These faults lie buried under salt, shale, and sediment layers, which dampen minor quakes, but also mask deeper tectonic shifts. Salt behaves plastically under pressure and can flow, silently accumulating stress in the surrounding rock. This phenomenon, called halokinesis, may contribute to unpredictable seismic releases. The Gulf's sediment-heavy structure complicates matters. Vast deposits compact unevenly, distorting strain fields and creating hidden zones of weakness. As energy builds beneath the surface, it may remain locked for long periods, only to release suddenly in powerful bursts rather than frequent, smaller quakes like those along San Andreas. This makes the region vulnerable to silent earthquakes, tectonic slips that quietly add cumulative stress. Offshore oil platforms, underwater pipelines, and seafloor cables crisscross this area. Built for hurricanes, but not for seismic rupture, they could bend or sever during a major event, triggering oil spills, gas leaks, and communication failure. Liquefaction, a process where saturated sediment behaves like liquid during shaking, could further compromise offshore rigs and coastal facilities. Critical ports like Houston and New Orleans could face severe disruption. With vital infrastructure resting above reawakening fault systems, the Gulf's seismic risks may be dangerously underestimated. What was once considered a quiet geological province is showing signs of renewal, and scientists warn that preparation is no longer optional. The signs are adding up. In addition to seismic detection, hydroacoustic sensors placed on the ocean floor have picked up unusual low-frequency signals known as tectonic tremor. This kind of seismic hum has been linked in other regions to slow fault ruptures and pre-slip behaviors, potentially foreshadowing larger quakes. Geodetic measurements tracking land elevation using GPS have detected minor vertical shifts along parts of the Gulf Coast, especially in southern Louisiana and Mississippi. While these shifts are small, they are persistent and consistent with crustal warping, a sign that tectonic pressure is not being released in a steady or uniform manner. INSAR satellite data confirms it. Ground deformation is happening, not just offshore, but inland as well. These satellite readings show measurable uplift and subsidence patterns, particularly near known fault intersections and salt dome provinces. These deformational patterns may signal deeper lithospheric adjustments that have yet to reach critical failure. Could this be the sign of a broader regional adjustment? Are the Gulf fault systems transferring stress toward the coast or receiving it from deeper tectonic interactions with the Caribbean and Cocos plates? There is also the possibility of stress linkage with the Mid-America Rift system, an ancient, buried fault zone that runs beneath the central U.S. No one can say for certain, but experts agree on one thing. The Gulf is no longer quiet. The signs of subterranean change are accumulating, and they're pointing to a system that may be more complex and more active than anyone expected. Infrastructure at risk. The implications go far beyond the ocean floor. The Gulf Coast is home to millions of residents, key military installations, and massive energy infrastructure. Dozens of refineries and petrochemical plants depend on stable seafloor pipelines. Ports like Houston, New Orleans, and Mobile are critical to U.S. trade, each handling millions of tons of cargo annually. A seismic disruption could grind this commerce to a halt, affecting national and global markets. A significant seismic event could trigger undersea landslides, rupture pipelines, and send shockwaves through supply chains across North America. Crude oil, natural gas, and petrochemical flow would be jeopardized, impacting not just industry, but household energy supplies and gasoline prices. Oil rigs anchored to the seabed could tilt or collapse. Many rigs rely on precise engineering tolerances to stay upright and balanced. A lateral or vertical shift in the seabed could stress their support structures beyond design limits. In extreme cases, structural failure could lead to sinking platforms, human casualties, and multi-million-dollar losses. Gas pipelines, already under pressure, might rupture, leading to catastrophic spills or even underwater explosions. Depending on where the rupture occurs, these leaks could take days to locate and weeks to repair, releasing harmful hydrocarbons into sensitive marine ecosystems and endangering wildlife and fishing industries. Even the seabed itself poses a risk. If fault movement triggers sediment slumping, it could create localized tsunamis, small, perhaps, but still dangerous to low-lying coastal areas already prone to flooding. barrier islands could be overtopped or eroded, and ports temporarily shut down due to surges. Additionally, shifting sediment can bury or sever undersea cables, affecting internet and communications infrastructure, vital to national security and commerce. These cascading failures underscore the interconnectedness of Gulf infrastructure and the need to reassess seismic risk across the entire region. What if it happens again? The Gulf has experienced quakes before, quiet ones. In 2006, a magnitude 5.8 earthquake struck off the Florida coast, catching scientists off guard. In 2010, a mysterious tremor shook parts of Louisiana, later linked to deep Gulf activity. More recently, smaller seismic swarms near the Gulf's central region have sparked renewed debate over the area's geodynamic evolution. But these may have been warnings. If a magnitude 6 or greater quake were to strike near the Gulf's fault system, the damage wouldn't be isolated. Ground shaking could propagate far inland due to the dense, old bedrock of the southeastern United States, a condition that enhances seismic wave transmission over long distances. Cities well beyond the immediate fault zone could experience structural damage, especially in areas with unconsolidated sediment. Coastal cities with poor seismic design, like Baton Rouge, Galveston, and even parts of Tampa, could suffer serious structural damage. Many buildings in these areas were constructed before seismic risk was a consideration. Brick structures, older bridges, and non-retrofitted public buildings may collapse or sustain irreparable damage. Bridges, chemical plants, port facilities all sit on soft soil or reclaimed land, vulnerable to shaking and liquefaction. Liquefaction could cause the ground to behave like quicksand, destabilizing critical infrastructure and making rescue efforts more difficult. Emergency evacuation routes may be blocked or rendered impassable. The cascading consequences could extend to water and power systems. Breaks in water mains, sewer lines, and electrical grids could lead to widespread service outages. Flood control levees and dams could be compromised, particularly if shaking occurs during a season of heavy rainfall or high tides. And unlike California, few building codes along the Gulf account for major seismic events. Preparedness drills are rare, and emergency services in many coastal counties are underfunded or ill-equipped for earthquake scenarios. Not even close. The Gulf states remain dangerously exposed to a threat many still underestimate. Monitoring the deep. Fortunately, scientists aren't ignoring the signs. The U.S. Geological Survey, NOAA, and international partners have launched new efforts to map the Gulf's fault lines in unprecedented detail. Ocean bottom seismometers are now deployed across key zones to detect even the faintest tremors. These devices are supplemented by hydrophones that listen for the acoustic signatures of shifting rock, critical for identifying deep or hidden fault activity. Pressure sensors are monitoring gas buildup in seabed sediments. Gases like methane and helium can be indirect markers of tectonic stress release. In some areas, autonomous underwater vehicles, AUVs, have been dispatched to collect close-range bathymetric and thermal data, helping scientists understand real-time deformation and identify potential rupture zones. In addition, new 3D seismic reflection imaging projects are underway, offering layered visualizations of subsurface fault structures and sediment patterns. These models allow geologists to simulate how energy might propagate through the crust in a future quake and which areas might be most at risk. But the tools are expensive and the funding is thin. Budgetary constraints limit the number of monitoring stations and delay the rollout of essential early warning networks. Some coastal regions, particularly in Texas and western Florida, remain under-monitored despite their proximity to key fault zones. Geologists are calling for a major investment in Gulf seismic research before a large event occurs. They advocate for public-private partnerships, expanded sensor grids, and federal recognition of the Gulf as a zone of seismic concern, not just a hurricane risk region. Because if history tells us anything, it's this. It's not a question of if the Earth will move beneath the Gulf, it's a matter of when. And the sooner we enhance our observational capacity, the better prepared we'll be to respond when that moment arrives. The ground is shifting. What scientists feared is beginning to unfold. The fault lines beneath the Gulf are not dead. They are stirring, quietly, slowly, but undeniably. And every crack, every tremor, every plume of gas may be a warning, because beneath the calm waters of the Gulf of Mexico lies a hidden network of tectonic tension, and it's starting to pull apart. So the next time you stand on a Gulf beach or watch an oil tanker drift across the horizon, remember, it's not just the waves that move out there, it's the Earth itself, and it may be trying to tell us something.